Assalamu alaikum wa rahmatullah. Hi everyone. In this video I will be doing question 2 and 3 from the first file of the free response questions for grade 12 elite for term 3. So question 2 in this file, we have a table of T and L of T, where L of T is the number of people, T is measured in hours. It says use a trapezoidal sum with the 3 sub-intervals to estimate the average number of people waiting in the line during the first 4 hours. Not the whole table, only 4 hours, and use the trapezoidal sum. So the question also says 3 sub-intervals. So the 3 trapezoids we are going to use are going from 0 to 1, 1 to 3, and 3 to 4. So the first trapezoid is going from 0 to 1. This value here is 120, right? And this value here is 156. This is the trapezoid. So the area of this trapezoid is half times, this is B1, this is B2, and this is H. It's 90 degrees rotated, so it's not a right trapezoid, it's rotated. So the bases are the two sides. So the first base will be 120 plus the second base will be 156 times the height, which will be only 1. It's the difference between 0 and 1. Okay, so this is the first trapezoid. Okay, now the second trapezoid, okay, is having half times the two bases are going to be 156 plus 176 times the height, which is the difference between 1 and 3, and the third trapezoid will be half times the first base is 176 plus the second one, which will be 126, right, times the difference between 4 minus 3, right? So those are the three trapezoids. Okay, those are the 3 trapezoids. So if we just evaluate them, the first one would be 120 plus 156, but you have to multiply it by half. The first one is 138. The second one would be 156 plus 176, that is 323, because 2 will be multiplied by half. The last one will be, let's do it quickly, 151. Now if you add those 3, 151 plus 332 plus 138, that is 621. Going back to the questions, to estimate the average number of people, so it's 1 over B minus A times the integral from A to B of what? L of T, dt. So this is going to be what? 1 over 4 minus 0 times the answer that we just got, which is 621. So it's going to be, if you multiply by 1 over 4, 155.25 people. So that would be the final answer. This is question 2. So moving on to question 3. second. Okay, just here is the third question. Okay. So in this question, we have an ice sculpture melts in such a way that it can be modeled as a cone that maintains a conical shape as it decreases in size. We have a table of T, R prime of T centimeters per day. Part A, approximate R W prime of 8.5, right? So we know that 8.5 lies between 7 and 10, right? So what we can do here, for part A, we can say that it's R prime of 10 minus R prime of 7 over 10 minus 7. Both numbers are given in the table, okay? They are what? Negative 3.8 minus R of 7 is negative 4.4 over 3. That would be 0.2 centimeters squared, per day squared. That is the first part. Now, the second part is there a time from 0 to 3 for which R prime of T equals minus 6? Well, here, if you look at only specific values, like what? The two given in the interval 0 and 3. Well, R prime of 0 in the table, it's minus 6.1, and R prime of 3 is minus 5, right? Now, this is a big question, can we insert R prime of negative 6 in this table? Does negative 6 lie between negative 6.1 and negative 5? Yes. So there should be a T value here. Okay, but we need to write what? A full comprehensive answer. We can say what? Yes. First of all, we have to mention that since R is what? Is twice differentiable, it is continuous. Continuous on the interval from 0 to 3. So, by what we did here is called intermediate value theorem, unit 1. So by the intermediate value theorem, there is a value T between what? Between T equals 0 and T equals 3, such that R prime of T equals negative 6. Part C says use a right Riemann sum with the 4 subintervals indicated in the table to approximate the value of the integral from 0 to 12 of R prime. So doing part D here, sorry, part C, the integral from 0 to 12 of r prime of t dt is approximately what? Write Riemann sum for subintervals. This is 1, 2, 3, 4. So the first one will be 3 minus 0 times the right endpoint, which will be negative 5, plus the second one will be 7 minus 3 times the right endpoint, which is negative 4.4, plus the third one will be 10 minus 7 times the right endpoint, which is minus 3.8. The last one will be 12 minus 10 times the right endpoint, minus 3.5. And this is simplifies to what? Let's check it quickly. This simplifies to minus 59.1. Minus 59.1. Let me double check. No, minus 51. Sorry, this is minus 51. Minus 51. Okay, so this is part C. Now moving to part D. What does it say? The height of the cone decreases at a rate. So dh over dt of the cone is decreasing, so it's negative 2 centimeters per day. T equals 3. The radius r equals 100. This is at t equals 3. The radius is 100, and the height at t equals 3 equals 50 centimeters. Find the rate of change of the volume. Find dv over dt when t is equal to 3 at t equals 3. This is what we need to find. So, how do we do so? We are given the formula of the volume, which is 1 over 3 pi r squared h. Notice that r and h are both functions of time, so we have first, we have second. To differentiate, to get dv over dt, you must use the product rule. So differentiate the first, you get 2 over 3 pi r times dr over dt. I differentiated the first, now leave the second, plus leave the first, differentiate the second. The derivative of h will be dh over dt. So dv over dt at t equals 3 equals what? 2 over 3 pi. The radius is given, it's 100. dr over dt, it's r prime. R prime at t equals 3 from the table. R prime at t equals 3 from the table. It's minus 5. It is what? It is minus 5 times the h, the height. The height is given, it's 50. Plus what? 1 over 3 times pi times r squared. The radius is 100 squared times minus 2. It's given. So this is all. Let me just do it quickly. Just give me a second. So this is going to be minus 70 thousandths pi over 3 cubic centimeters per day. This is, it's a long video, but it's basically 2 questions in it. Question 2 and 3. All the best.